So I think most people on this call already, they've heard the word varnish. And when they heard varnish, they're not talking about the wood stain or anything like that. Their associations with varnish are not as pleasant as that one, right? So before we get into that, I'm gonna just give you a little bit of a brief overview so a little bit of my background. I am the founder and the managing director of Strategic Reliability Solutions Limited, based in Trinidad and Tobago in the Caribbean. I am also the co-chair of Lubrication and Reliability Virtual Summit. If you have not heard about that before, then I probably haven't done my job very well. But let me know if you're interested in attending. I can always see what I can do in terms of tickets. Now, I know we have some Trinidadian audiences, so I'm gonna just say that I am past UE alumni. I have my BSc in Electrical and Computer Engineering, my MSc in Engineering Asset Management. And over the years, I would have, accumulated different certifications, different badges. I was the first person in the Caribbean, and I think still the only female in the Caribbean, to actually get my MLE certification from ICML. First female in the world to get the Varnish badges from ICML. And I have the MLT 1 and 2, which for those of you who are familiar with ICML, you do not necessarily have to do those first. I'm just saying, you can do your MLE first if you want to. I went the opposite routes. But I have a lot of different things that I do as well. So I'm on the board with Precision Lubrication Magazine. And if you're not familiar with that, again, check it out, Google it. We do a lot of topics related to reliability and lubrication. So I write for that a little bit. Wow, it seems like I do a lot of writing. So I know a little bit about oil. I have written a couple of, maybe five books so far internationally published. My first book, Lubrication Degradation Mechanisms, A Complete Guide. I did another one with CRC Press, but sort of in the same vein. And this one was co-authored with Bob Latino. So we talked all about root cause analysis. I think the first presentation that I gave for APETS was about microdieseling. So it followed how to do root cause analysis. So that's, I did the guide for MLT 1 and 2. I did the book before I got the certification. So the book works, just in case you're wondering. I did Empowering Women in STEM. Really love that one because we have stories from men and women across the globe, just, inspiring other people. And my most recent book with Greg Livingstone, all about preventing turbo machinery cholesterol, the story of Varnish. I know at least 2 people, 3, maybe 4. So you all message me in the audience if you already have that copy of that book. So that's the latest edition that came out, the latest book that came out. There are a couple more books on the way, but I don't know how much I could say about that, but I'll leave it there. I am one of a technical editor for STLE, and of course, the series editor with CRC Press for Empowering Women in STEM. There is another book coming out with Empowering Women in STEM, possibly by the end of the year. So look out for that one. So that's just a brief summary of my background, because I know sometimes people need to know the background. All right, so now the reason that we're all here, what is varnish? So a lot of times people use the word varnish and they say, oh, we have varnish in our equipment. And some people don't even know what that means exactly. But ASTM has actually, they've done a full definition for it. And they say that it's a thin, hard, lustrous, insoluble deposit. I want you to pay attention to that part, insoluble deposit, that consists of a wide range of colors and is resistant to removal with saturated solvents. So they have a full definition of what varnish is. So within our industry, every single time we have some sort of a deposit, somebody immediately says it's varnish. So just to let you know, there is a full definition for it. ASTM, they've talked about it. So that you know, there is a definition, right? Now, people confuse, I wouldn't say confuse really, but they kind of use the words varnish and sludge interchangeably. So what we like to try to do is sort of define the two of them. So one of the main differences between varnish and sludge is that when you have varnish being deposited on the inside of the equipment, you can't remove it as easily. But with sludge, you could probably wipe it away. So there are times that people, you know, when they're talking about, especially operators or mechanics or anybody else in the industry, they're like, we have some sludge. But, you know, at the same point in time, it could be varnish. And then some people say, well, we have some varnish, but it could be wipeable. So it may be sludge. And it's very important to really know the difference between the two of them, because if you don't know what you're labeling it as, then you're not going to be able to treat it. So, and this is a really bad example that I'm going to give here, but you can't say, I had a headache today versus I had a heart attack today. They are two different things, and you would have to be treated differently. So just so you know, I'm not saying that varnish and sludge will give you a headache or a heart attack. Hopefully not, but they are different. So just bear that in mind when you're talking about it. Now, there are different types of varnish. Sometimes people, they are not entirely sure about this part because we go back from the beginning where they think that varnish is sludge and sludge is varnish. So there are two main types, and those are hot varnish and cold varnish. Now, the main difference here is that with the hot varnish, only at the heat source, that is where you get the varnish being formed. And these are a little more difficult to identify, because if you're looking at your equipment, then it's a little bit challenging to actually pinpoint that you have that temperature rise in that particular spot. So sometimes it's not as easily detectable until you pull the equipment down, or you get into it and you actually see what's going on. So one of the main solutions to that, and I would say it's like the easiest solution, is using something called a solubility enhancer. So that gets into the equipment and actually dissolves the varnish. Now, the other one that I think everybody is familiar with is cold varnish. And what happens with cold varnish is that this is when you have a full accumulation of whatever degradation product that you have. And once it gets to that saturation point in the oil, it's going to come out of the fluid. It's going to go onto your internals of your equipment. Now, what I want you to think about is if you're doing like a cup of tea and you're adding, so let's assume you're not doing iced tea, you're doing a hot cup of tea, right? So if you have boiling water and you add sugar to it, you can keep adding sugar until it gets to that saturation point, right? Now, if it gets like you had something to do and the water gets cold, you'd realize that a lot of the sugar would start coming out of the hot water. So that's kind of like what happens with cold varnish. So only when you reach that saturation point and all of the deposits starts coming out, that's when you have cold varnish occurring. But it has to get to saturation points. And in this one, it's most easily detectable through your MPC, because what you would do, and let me backtrack a little bit. Your MPC is your membrane patch coulometry test. It's really like a patch test. And that would sort of, I want to use the word strain out some of the deposits. So you'll be able to actually find those before. So cold varnish, very easily detectable through MPC. So hot varnish, not as much, because of where it's being formed. And sometimes you may not get that oil to be fully representative of what's going on the inside there. So just so you know, there are two different types of varnish. You have the hot varnish and you have the cold varnish. Now, I want to ask, and Darrell or Leslie, you all will help me out. Within our industry, and I remember because it's around some of the time that I first started in industry, a lot of people began saying that the group 2 base oils were completely responsible for varnish occurring, right? So I went to, I'm not going to call the name of the plants, but I went to a couple of the plants, major plants in Trinidad, and a lot of them were like, yes, it's because we have the group 2 base oils. And that's the reason we have varnish occurring in our equipment, because we had group 1 base oils before and we had no varnish whatsoever. But since they did the switch over to the group 2, that's when they started to see varnish occurring. And I remember very, very distinctly that some of them were trying to get back the old formulation of the product with the group 1 base oils, because they were so convinced that it was because of that reason. That's why, all of the equipment started to have varnish. So I'm just going to ask the audience, for those of us who are in the audience, do you think that there's any truth that the group 2 oils are, responsible for the upsurge in varnish? Let me know in the chat. And I think, well, Darrell and Leston, you'll have to help me out there.
Yeah, no problem. Everyone, you could type in the chat.
Yes, please type
Truth
in the
or
chat.
myth?
Yes or no? Because I remember that time, and a lot of people were very upset that there was a change to the group 2 base oils. So I'm gonna give you all like a few minutes to think about that a little bit.
One person said not.
One person said not. Okay. All right. Let's see if we get some other people chiming in there. Because
repeat the question.
Repeat the question. Or the one that's on the screen.
Right.
Do you think that the group 2 base oils are responsible for the upsurge that we had in varnish?
Right.
What do you think about that? Like, I definitely want to hear your thoughts on that.
Come on, guys, don't be bashful.
Let me know what you think.
So, our next person said not.
Not. Okay, we have
our next person say myth, so not.
Okay, all right. Good.
David Turner, Mr. Turner said
Mr.
yes.
Turner.
Yes and no. Let me read out his response, right? Yes and no. Group 2 oils have poorer solvency than group 1, but the additives that were used in group 1 turbine oils did not work as well in group 2. Modern turbine oils with better suited additives produce less varnish today than they did 20 years ago.
Definitely,
food
David.
For thought. Yes,
definitely,
food for
David. Thought. Definitely. So, David brought
me to
my next slide. So, what happened is that in like the 2000s, varnish was very rare. A lot of people did not know, or it really wasn't occurring, or they think it wasn't really occurring. But like everything in life, we had a lot of evolution. And what I want you all, because I know we don't have extremely, like, we don't have 5-year-olds in the crowd. So you all will realize, or you all will remember that maybe like 20, 30 years ago, a lot of the cars were a bit bigger, right? And with a bigger car, you have a bigger engine. And those engines progressively over the years would have gotten smaller. So like the engine in my car right now is small compared to what it would have been like 20, 30 years ago. So a lot of changes happened within the industry. The OEMs, they got smaller sum sizes, everybody wanted smaller pieces of equipment, and the oil still had to do the same work. Same work they had to do, maybe a little bit more, because they had to be more efficient. And then you throw global warming into that, and they have carbon emissions to deal with as well. And they had a shorter time in which to do that because it's a smaller space. So while that happened with car engines, it also happened with industrial equipment. So a lot of times you would have seen that we had changes in the industry. And that's what sort of made the change. Now, going through your group 1 base oils versus your group 2 base oils. Now, group 1 base oils, they have a higher aromatic content. So what that really means is that it has a higher solubility rate, and it allows deposits to stay into solution longer. But this doesn't mean that it produces less varnish. Definitely not. It just stays longer in solution. Now, your group 2 base oils, and there's a reason, we evolved, we were able to refine these base oils a little bit more. They actually increased the performance for thermally stressful applications. So they had a higher resistance to oxidation. So just, comparing your group 1 to your group 2 base oils, because, I have to make sure you all understand why we're saying what we're saying. It's a myth. And what happened is that Greg and the team at Fluidtech, they actually performed a turbine oil performance prediction test. That is a mouthful. And that's based on the stress conditions that, you would use in a dry TOSD test. And that's like pushing the oil until the point that it cannot do anything else. And what they realized is that your group 1 base oils, just after 4 weeks, this is what your MPC patch looked like. However, your group 2 base oils, it took them about 12 weeks in that same test to get to this state. So initially, I know when varnish started to occur and it started to happen, everybody was looking for a factor to blame, somebody to blame, and David gave a great response. Thank you, David. So it's really not that because we had to change from group 1 to group 2, because we've seen a group 1 versus a group 2 base oil after it's gone through this testing. And yes, the additives would have changed as well. So there's a lot of evolution within the industry. So for everybody who said no and who said a myth, well done. You all should let you all run the presentation because you all know this stuff. Now, another thing that we talk about is that we always talk about organic and inorganic deposits. Now, one of the main reasons why this actually matters is that you need to understand and you need to know the type of deposits happening in your system. Because if you know the type of deposits, then that means that you can actually determine the type of degradation that is going on in your system. So there's a difference between your organic deposits and your non-organic deposits. Now, you can also classify deposits as water lubricants as well. But for your organic deposits, and I'm not going to read out the list here for you. I know you all can read that out. But there is a difference with it. And being able to detect that could tell you if you're having oxidation or thermal degradation. So that's one of the things when you have varnish occurring in your system that you want to make sure that you determine early on. So just trying to break it down a little bit further, for your organic deposits, these are usually soluble in the lubricants and they can easily transition in and out of the solution. But usually that's based on your oil's temperature. Now I have the list of the same list of the stuff that we had before. Which are non-organic deposits though, these are usually your wear metals and dates. So what I want you to think about here is that you can also have some sort of carbon or hydrogen functionality with them. And when you have different variations of coal or soot or tar, these sort of things that are non-organic, most of the times there may be thermal degradation happening inside there. So being able to identify the difference between your organic and your non-organic deposits can help you to determine what's going on with your system. So very important for you to note. Now, another one. So I'm just doing this in the form of questions, right? Some of the factors, what are some of the factors that can affect the formation of deposits? So a lot of times we get asked this question because a lot of the operators are like, okay, so we have varnish occurring. What can we pay attention to? And if you have varnish occurring, you need to be paying attention to a lot of things. But there are four main factors. You need to know your mode of degradation, your temperature, your temperature of your reactions, the type of contaminants, and the chemistry of the oil formulation. So these are all different things that operators need to pay attention to, because if your deposit is forming, you need to know how you can actually treat with that. So if you're looking at your mode of degradation, and for those of you who know, I love to talk about the 6 different modes of degradations, right? Being able to assess the degradation mode helps you to identify. So if we have like oxidation occurring in the system, then that means we're looking for free radicals being formed, or we're looking for different things like all of the antioxidants being depleted early enough. And knowing that means that we need to understand why, in the first place, your free radicals are being formed. Why are they depleting your antioxidants? Is it that your antioxidants you don't have enough antioxidants in your oil? Is it that because of your system, you're having more free radicals being formed? Or is it that you're having a catalyst in your system? So, we could talk all day about this, but understanding the mode of degradation is important in terms of identifying what's going on. And that starts with your deposits as well. So something for you to note. And when we talk about varnish, we always talk about temperature. So like you need to note what's the temperature of your different reactions. So if your temperature changes, if you start noticing different changes in your temperature, sometimes a lot of people see like a sawtooth pattern of temperature. So that could be when you have varnish being accumulated on a shaft and the temperature would keep going up because it's insulating. And if it's on the shaft, it may get to the point where it becomes wiped away, and then you'd see a temperature drop. And then it starts building up again, and then it gets wiped away, and the temperature drops again. Because I remember very clearly working with some of our clients in Trinidad, and they were like, I don't understand what's going on. Why do we have a sawtooth pattern of temperature? Like, that's not supposed to happen. So it's very important to note like your temperature, especially of your reactions. Because if you start seeing temperatures, let's say in excess of 200 degrees Celsius, you can suspect that you have thermal degradation going on. If you start seeing temperatures more than 1,000 degrees Celsius, that may be microdieseling. More than 10,000 degrees Celsius, you probably have some sparks in your equipment, and you may want to check your filters for being burnt. So temperature is very important when you're thinking about varnish. So another thing to note, now I think at the beginning of the presentation, we talked about varnish having different colors. Now, with varnish, it would always change depending on the chemistry of your oil formulation. And every single oil, every single type of oil, every single brand of oil will have their specific additives, their base oils, the ratios. So the way that one company will blend a particular hydraulic oil will not be the same way or the same additives or the same ratio that another company would use. So that's why they're proprietary. But, chemistry of your formulation actually helps you determine what's going on with your deposits. So your deposits will only form depending on your chemistry of your oil. So if you're looking at some of these, oxidatively derived deposits, you're going to start seeing that those deposits actually have a lot of decomposed antioxidants. So that's why your chemistry is so important. And sometimes people forget to think about the chemistry of the oil, and they just, say, okay, a deposit is a deposit, and they just don't take it on. But the chemistry is very important of the oil because sometimes different additives react differently in different environments. So very important for you all to note about that. The last one is the type of contaminants. Now, contaminants, nobody wants that in their system, right? But they can act as a catalyst for varnish. And sometimes a lot of people, when they're talking about varnish or they're talking about the different modes of degradation, they don't talk about contamination, but that is one of the major modes. And sometimes if you have contamination occurring, that can lead to other modes of degradation. So if you're doing your root cause analysis, you need to go all the way down and figure out the real reason that you're having varnish occurring in your equipment. Because if you stop and you say, okay, well, it's oxidation, but you're having oxidation actually occurring because of contamination, then you're not going to solve the real problem unless you remove the contaminants. So it's very important for you all to note the type of contaminants that you're having in your system. And, there are some contaminants that you can predict that they're going to be in the system. If you're looking at like an ammonia system or something like that, at some point or another, you're going to get ammonia into the oil. So that's one contaminant you could expect to see in your oil. But, it happens sometimes. There are some that you cannot predict, and somebody goes and they put engine oil into your hydraulic system. It's happened so many times, and I've had so many people call me about it on boats or different things, and they're out in the middle of the sea and somebody put the engine oil into the hydraulic system. And I'm just like, oh, I'm sorry, y'all definitely need to drain that, because if you move any further, something's gonna happen. So contaminants, you need to know what contaminants you have in a system. They highly influence the type of deposits that you're gonna get afterwards and the amount of trouble that you probably have afterwards as well. So another thing a lot of people ask when it comes to varnish, and I know we talked about it initially, we talked about the temperature being very important. Now, sometimes in these systems, there are three main things that I want to say help to control your temperature. So your deposits will come in and out of solution, especially for those who are doing, I know we're entering shutdown season in a little while, but everybody's going to be shutting down. And when they shut down, what happens is that the oil gets cool and, deposit starts coming out and nobody checks the lines before they start back up. And then they realize, we have some varnish in there afterwards. So one thing to note as a side note, always check all of your lines. If you are shutting down and your oil is remaining in that system, there may be a tendency for varnish to form. So it usually forms on the cooler areas, and especially those last chance filters. Those are the ones that get it the most. So even if the oil is not cool and they're under high temperature or high load, deposits will come out as well. So just something for you to look out for. And some ways that you could sort of control your temperature is that you have oil coolers. I know we think we're in the Caribbean and it's always hot here, so you don't need an oil cooler. But sometimes, we need to make sure that we have the temperature of the oil being maintained. And what happens from time to time is that the oil cooler may not be working, or it may not be, functioning properly, and it's either heating up the oil or cooling it down too much or not doing anything at all. So always make sure that your oil coolers are actually working properly, and that's how you could control your temperature. Another thing you can look at is your heat trace lines. So your heat trace lines, those are the ones that you have going to your equipment. And what they do is that they try to keep the oil at a particular temperature. Because what we've realized is that once the temperature drops, similar to the example we gave at the beginning, some of your deposits start coming out of the oil. So these heat trace lines, very important for those last chance filters, especially if you have like electrostatic spark discharge occurring. The heat trace lines are very important for that. It can help mitigate that in some way or another. And another solution you can use is actually having a properly sized and functioning heater in your reservoir. So sometimes what happens is that we need to have a heater in the reservoir and we don't have the right size for that particular reservoir. So we're just, swapping out and we're like, okay, well, you know what, this should actually work. But sometimes it heats the oil too much or it doesn't heat the oil enough. So ideally, make sure that you have the right size of heater for your reservoir, because that can actually contribute to you getting deposits in your oil. So something for you to be aware of if you're looking at controlling your temperature of your oil to sort of prevent varnish. 3 main areas that you can look at. All right. Now, we always get a question about what is the budget-friendly test that we can do for turbine oils and to try and monitor their degradation. Well, the short answer to that is that I don't know what your budget looks like, but if the turbine goes down, you're going to find the money somewhere to get it to go back up and running. So paying for oil analysis tests is not much compared to getting your turbine go down for a day and you have everybody on your back saying, when are we going to get the turbine up and running? So a loss in production, especially in the power sector, can cost you millions compared to just putting the extra few $100s at the end of the month, or 2 or 3 times for the year, depending on the type of test that you're doing, to actually, make that investment towards monitoring what's going on with your oil. And it's similar to, I really don't want to use these analogies, but it's similar to taking blood tests or checking up on your cholesterol throughout the year. So you may do that as a yearly test, or some people who are more prone to it may do it twice for the year. You don't want to wait until you get a heart attack, then to go and test to figure out if you have cholesterol or not. So just, lightening it to that. We don't want to go through the heart attack and all of that. We'll just test before, just a little bit of blood that they need, and make sure that we could find that out in advance, because very important. Now, going back to the actual machine and not with humans anymore, some of the tests that you can use to determine if you have some sort of degradation going on, the ruler test is really good. That actually monitors your presence of your antioxidants. And sometimes I've realized that some people when they're giving a reading or the results for a ruler, they just give one value, and that's not entirely accurate. They should give two values for your amines and for your phenols, because you have primary and secondary antioxidants in your oil. And in particular for your amines and your phenols, they have a bit of a synergistic reaction in that when one depletes, another one sort of regenerates it. So if you get one result, which would be accumulative of the two of them, it's not entirely accurate to let you know that you have one of them depleting and one of them not depleting. So just as a side note for you all to know, if you're doing the ruler test, get those two values and not just one. But typically what happens with your ruler test is that it measures your antioxidant levels. And once those levels go below 25%, that's when you start having issues. So the threshold for the ruler test is actually about 25%, but you should start getting worried, a little bit before, because once it goes past the 25%, that's when you start seeing very rapid degradation. So that's when we don't have as much time as we thought we did to rectify whatever's going on. So they use 25% as the threshold. That's their value. Another test is the MPC test, which we spoke about earlier. I believe that they have changed some of these values a little bit in the latest. I have David Turner with me. David might be able to help me with that. I think I heard that they changed some of these indicator values a little bit earlier this year. So typically when you get the values, it's usually between 0 and 15 is considered normal. Between 15 and 30 is monitor. 30 to 40 is action, and more than 60 is absolutely critical, because that means that you have way too many deposits in there. You do not want to get to, I think you don't want to get past 30, but that's just me. But definitely when you're looking at your results, you want to make sure you know what your limits are. And another thing to note with this as well is that while these are general guides, some of the OEM and some of those different OEMs, they have different values for different pieces of equipment. So if you have, I know like for GE, for instance, two of their turbines, they have different levels that they call critical. So one of their turbines might be 10, the other one may be 12 or 15. So it's always good to check back with your OEM to make sure that you have the right levels, the right criticality levels for these. Another one that you can look at is the CPA, and that's calorimetric patch analyzer. Now this one, a lot of people don't necessarily use this one as much because MPC, they take the spotlight, but CPA could actually use, it gives a little bit more information because of the way that the test is structured. And when they do, it's the same concept as MPC in that you have the patch test. But what happens is that when you're analyzing the patch, you don't just analyze the light that is being reflected, you analyze the light that's being transmitted. So with the light that's being transmitted, you actually get the surface and the inside of the patch. So that's very different from the MPC, where you just have the reflection of the surface alone. So something to look out for, to look into. We also have the RPVOT test, rotating pressure vessel oxidation test. And while this may not be my favorite test because it's not as repeatable as some of the others, I know it has been an industry standard for quite some time. So it is something that a lot of people still use. A lot of OEMs have particular values for it, but just be aware of the values and the criticality levels for this one. Personally, I don't really like it, but that's just my opinion. I'm not here to influence your opinion on that. So another test that you can use would be your particle counting test. And that can help you to, if you're trending, because when you're talking about oil analysis, you're always doing trending. That helps you to identify if you have an increase in the amount of particles over the period of time. And that may give you some sort of indication that you have varnish present. So just some tests that you can think about. And these are the bigger ticket tests. They're slightly more expensive, but you would want to do these tests because I know we get a question based on the frequency, like how often do I have to do these tests? Do I have to do them every week? Do I have to do them every month? And that would really depend on your system and what you're trying to track. Because if you're now doing a startup of your system, and let's say you want to track how your oil performs in the first year, you may want to do samples every month, just so that you have a really good baseline. You may not be able to afford to do samples every month, but depends on your budget and what you're trying to achieve. And probably when your turbine gets into its later stages, you may want to cut that back to like 3 times a year or 4 times a year. But it really depends on what you're trying to achieve and the criticality of your system, because criticality of a system can determine how often you're going to do these tests. Because if it is a turbine oil that you're not using, it's a secondary piece of equipment, you're not, well, I wouldn't spend as much money getting these tests done every single month compared to another piece of equipment that is highly critical. If it goes down, the plant fails, that's the one I want to be monitoring all the time. So it really depends. Your frequency depends on your equipment, what you're trying to achieve, and of course, some budget constraints. I'm going to use that loosely, some budget constraints. So I think that was it for me on my side. So I think we have about 12 minutes remaining. So Leston and Darrell will have to help me out with any questions that we have so far.
Yes, do we? Yes, people. Thank you, Sanya, for that presentation. Very detailed,
Welcome.
a lot of knowledge base.
Oh boy.
Guys, ladies, do you have any questions? We have David Turner saying, excellent webinar, thank you.
Oh, thank you, David. I always like to hear from you.
Are there any questions with regards to the topic at hand? Come on. Don't be shy.
You all have questions.
But when it comes to Varnish, there's no such thing as a stupid question.
Oh yeah, there are no such things as that because everything is fairly new and we're still... Oh, your Quinn has a question.
Your Quinn. Christopher said, great presentation. I am going to try to unmute you, Quinn.
Yes, if you can. It might be easier to do that than for him to type, because like sometimes it doesn't work.
Your Quinn.
All right.
Hello.
Take a shot at it.
Hi.
Yes, good ahead. We are hearing you clear. Go ahead.
All right, nice. I really appreciate this presentation in terms of the definitions and the information that was presented, some of which I wasn't too clear on. My question is, you spoke about the initial testing to determine, what's the state of any varnish in the system.
Mm-hmm.
So you determine that the system has a lot of varnish, etc., etc. and we are looking at addressing the issue.
Right.
So you will have your standard processes to do with the different units to remove the varnish. Which do you recommend in terms of efficiency and cost?
So that is a great question, Yuquin. Thank you for asking that.
The reason I'm asking is I'm not an engineer. I'm a technician, but I'm a field technician, and
you are the eyes and ears on the ground. Like,
yes,
you see when this is happening, you know,
yes.
you can tell the difference in the sound of the engine and just by passing by the engine. So thank you for everything that you do, first of all.
Yes, thank you. Of course. I have almost 10 years first-hand experience doing these tests on turbine sumps and so on.
Great.
And what has become clear to me is that many of the people who make the decisions in the plants, they are not sure.
Yes.
They are not aware of what direction to go in terms of from testing all the way to, okay, we have varnish and we need to fix it.
What do we do?
What to do, which is, and then after we fix the problem, how do we mitigate after?
Yes, definitely. I love your train of thought there.
I think, discussions like that needs to happen, because I was an unfortunate victim in an incident in a plant in the past where I passed out in the turbine sump after we circulated the oil to remove the varnish, and I was the technician to go in and physically remove the remnants of the varnish. And I passed out in the turbine sump because the temperature rose by 30 degrees in less than 5 minutes.
Yes.
And,
oh my God.
Yeah.
That is a traumatic experience.
It was. But what struck me is that from the plant personnel come straight down to the ground crew, there wasn't this decision making wasn't happening promptly as it should have on how to proceed with each stage, and I believe it was a lack of knowledge.
Yes.
So how do we address that?
So I think the first thing that we usually do when you have and you've identified that you have varnish in your equipment is really to test the varnish. And we spoke about it earlier in terms of the chemistry of the varnish, how has it been formed? So those things help us to understand why it formed in the first place. Is it that we are doing something wrong with our system? Is it the environment that's going on, the temperatures? We change the operating temperatures a lot or too much so that the oil is getting to a point where it cannot handle everything that is going on with it. Is it that we're introducing contaminants in it? Is it that the oil that we chose just really can't make it with our system requirements? And you have a lot of additive dropouts, or you have your antioxidants being depleted. So that's where you do your full root cause analysis. But
sorry to cut you, but that time it was all of the above.
Oh boy, you really had a traumatic experience.
Yes, it was, because I studied the entire project very detailed. It was all of the above, but there was a lack of reaction. From getting all this information. I believe they did MPC tests to determine, hey, listen, we have varnish and we need to bring in the guys to bring in the isopure units, and we used something called Boost VR to introduce the
that's
system.
Actually pretty good. Yeah.
Yes, it is. And from the results of the test, everything was supposed to happen long before, because we actually had to introduce multiple units to that one sump to
at that point.
Yes.
Yeah.
You understand? So
it went on too far.
Yes. And the engineers in the plant were asking us, the technicians, well, how and what and why and when. And we are saying, you are the engineer supposed to have this information.
And that's why I'm so glad that you attended this seminar today, Yoquin. So I know you will be sharing your knowledge, but one of the main things you do, the first thing is identify what type of deposit you have going on so you can prevent that from happening in the future. Now, the next part you need to do is get rid of that varnish that you have in your system. And sometimes people do a flush, they do a mechanical clean. It really, really depends on the extent of varnish that you have in there and the type of varnish as well. Because there are solubility enhancers, like you mentioned, Boost VR, that can sort of degrade that varnish that you have built up, but it will take some time. And that's the thing about those.
But what I also notice, I'm also working in a plant right now, and we're working on the turbine sumps. And they did their tests as well, and they determined that the course of action is to change out the oil.
No, that never works. I'm sorry.
To degrade, before it starts to degrade, right? Trying to preserve the system. So we've been moving from turbine to turbine, draining the oil, changing out all the mechanical parts, and then they pump new oil in through the filter system, and then boom, starts.
Okay, so let me walk you through this.
the reason I brought it up is because their valuation is that it's cheaper for them to change the oil.
It's so not, because the money that they save when they change that oil and they do that new sump replacement, it's what happens is that if you do a new sump replacement before the oil varnishes, or before you think that it varnishes, because you're gonna have precursors in that oil and precursors that would stay on the inside of the equipment, by putting new oil in there, you're already contaminating the new oil. So your chance of varnish is going to be twice as high compared to your first set of oil that you had in there in the beginning, because you're putting new oil in there that is going to be contaminated with the varnish that you have in your system already. And it's your system that's helping you to produce that varnish. You haven't changed a thing with your system, and putting new oil in there doesn't work. I'm going to give you an example, Yoquin. So if you go to the doctor and you have high cholesterol, do you do a blood transfusion? Do you change your blood and say, okay, well, I'm going to hope for the best? No, right?
But
you change your diet.
Transfusion is going to introduce more dangers.
I'm glad you think so. So it's the same thing with your turbines.
But this is really a lack of knowledge, because
yes, it is.
They are changing the oil, and there's no, so this is oil we're talking about, and you're talking about clean oil, whether you're changing oil or you're filtering the oil. And apart from the equipment being proper and you use the proper filters, you need to have the area well cleaned, blocked off from external. And this is not something that they express. So basically, the people are filling back the oil, and they're filling it back in a 4x4 foot opening, and there's no covering over the opening. There's just a hose goes in, and then they dump they refill the oil, not paying attention to the sump being open to the environment.
I'm so glad you're here with us today, Yoquin. So glad you're here with us.
So it's like it's not really spinning your top in mud, as we say.
Yes,
but
you are. They are. Sorry.
You're not starting when you start back up that turbine. You're not starting at zero contaminant. So you're starting at a height already, and they don't seem to understand this. And this is a problem I have being the frontline person, because I'm seeing it there. And I'm trying to explain, listen, the process to refill, to filter, whatever is very important, but these little things are equally important, because this is all we're speaking about.
They are very important. Like the amount of time, downtime, manual labor, cost of everything else involved, that is what's gonna drive up your costs, in addition to having to go and do all of this, repair all of the damage that was done simply because you didn't clean your equipment beforehand. You left all of the contaminants and the varnish in there. So your new oil is going to be contaminated. Like, it's not going to last If it's supposed to last 10 years, it may last 5 or 2, depending on the level of contamination. So you're gonna end up in a lot more financial crisis and operational crisis further down the road.
Yes.
And
now let
closer.
me ask this question.
Yes.
So I'm the person on the ground floor.
Mm-hmm.
You're the expert.
Oh boy.
How do I change that narrative? Because I think that is the bigger issue. We in Trinidad, we haven't fully accepted to conduct our maintenance proactively. We are still on this.
It's not just Trinidad.
I understand, but we're here, so we're dealing with
yes.
Right? So we're still on this run to fail kind of mode, right? And for some reason, there isn't this mainstream comparison of this versus that. So how do we change that narrative?
We start with sessions like this and having people like you attend and spread the word, and just starting the education process and starting to get people involved in conversations that involve these sort of topics and starting to get them to think a little bit. So what helps a lot is just giving them the same explanation that I gave to you. If you had cholesterol in your body, would you do a blood transfusion? So that just starts to get the gears turning. And then they're like, oh, wait, would I want a dirty needle? Similar to what you have with the turbine going on right now. Would you want that being the point of entry into your bloodstream? Definitely not. Right. So if we're not going to do it to ourselves, let's not do it to the equipment, just saying. So start with those conversations. And I see that Tanraj has his hand up as well.
Yes, I will unmute Yoquin. Thank you very much for that invigorating conversation. As usual, as customary. I will put you onto Tanraj.
Yes.
This will be an interesting question. I'm pretty sure. Tanraj, take the floor.
I think he's still on mute.
Well, I unmuted him, so
okay.
So
we may need to do it from your side, Tanraj.
Tanraj, you have to unmute yourself.
Oh yes, I think.
Yes.
There.
Good morning to all. This is your time about 8 o'clock.
Yes.
Before going office, thank you very much. Very good seminar. I seen a lot of very interesting discussion about the important ruler and MPC. I have some basic questions. Don't mistake me. Suppose if the customer asking what to do in between 15 to 30 or 30 to 40, how we can recommend whether we can partially replace oil, or we can recommend to do the whatever ESP, SRB treatments, or what type of, because sometimes from monitoring stage, we do not know what is causing this type of issues. So in that case, what type of recommendation we have to give to our customers?
So you always give a very interesting question, Tanraj. So I'm just gonna repeat it and you help me to make sure that I got it right. So if the customer has an MPC within the 30 to 40 range, and they're asking you for some sort of feedback, like what do they do? And you don't have the time to investigate fully, but they need to have their equipment running. The equipment cannot stop. What do you do? Did I get that right?
Correct.
Oh, yes.
No,
great.
actually, it's not like that. Every day we are receiving around 100 samples MPC. So if 1 or 2 samples have they are doing replacing oil or something, they are able to control the MPC level. It is going on increasing, but ruler okay or RBOT okay. but
Okay.
unfortunately MPC increasing. So I have
Ah,
to recommend every report, my diagnosis, I have to recommend, or my junior diagnostician to recommend to the customer, all big customers, not small customers. So they
okay.
are asking what we can do. So next time
Okay.
we are telling you replace 30% oil or 10% oil or filtering, something like, but still not the same line, or it is increasing line. In those
So,
cases, how we can handle the situation and recommend to the valuable customers that you can do this one, we can eliminate, or what kind of advanced test we can do to find out cause for the issue. We know
right.
that there are a lot of problem creating the varnish. So to find out what type of issue, we have most of the tests for RBOT, ruler, and other tests, but varnish, the dividing and ruling time. So what is the so many problem? Which problem causing the issue of creating that particular turbine or compressor?
Right.
How to find out that one?
So I'm just gonna translate a bit for those who may not understand the Singapore accent, a little bit.
Okay.
So
Sorry.
what
No,
I
I'm not.
what I got from it
Okay.
is that you have a customer, and what they are experiencing is that they have good values for ruler and RPVOT, but the MPC value seems to be getting in a high range. So your MPC is showing that you have varnish in your equipment, but your ruler and the RPVOT is not picking up on that. So in that case, what I would suggest is that if they can, open their equipment and actually get a physical sample of the varnish. Because what tends to happen is that if you do not have oxidation occurring where your antioxidant levels are being depleted, you're not going to see any relevant results on your ruler, because that's what your ruler is measuring. So that's why your ruler value would be different from what you see with your MPC value. Once you get your actual deposits, you would want to do an FTIR, Fourier transform infrared, on that actual deposit, so you can identify what particles or what type of components you have in that varnish. Being able to identify that can help you to understand what is causing the deposits or how the deposit is being formed. And before you start changing out oils or doing anything else like that, you need to understand what is going on the inside of your equipment. If you have that sort of time to play with, in that it's not heavily varnished. So the main thing I would say, the first thing is get into your system and see if you're actually seeing the varnish, or if you could get a sample of that. So that would be your first thing. Identify what your deposit is about, characterize it as much as possible to help you to identify your different modes of degradation. Your Quinn would be great in this because he'll tell you what has been happening with the equipment in the field, any sort of changes that he's seen. So talk to your field technicians, let them find out if they've seen anything, if they've heard anything, because sometimes with different types of degradation, you will get different types of deposits. So while your MPC may be coming back really high and your ruler is coming back normal, RPVOT is coming back normal, you need to identify what's causing the deposits and what's causing that MPC value to spike so high. And I would look at the trend of the analysis and see if it is related to a change in the equipment. So sometimes, some random times, maintenance may do things that operations may not know about. So talking to your people and your teams are very important, because sometimes maintenance may think, oh, we need a top up of some oil, and they may choose to use a different type of oil than the recommended oil. So it could be like human error at the end of the day, but you would only find that out when you start talking to the teams and going into detail with that. But definitely, if you could grab a sample, a physical sample of the varnish, get it back to the lab, analyze it, determine what's going on with the different components, what you have in that varnish, that's where it starts. Did I help you to answer that question?
Yes. Thank you very much.
Okay,
And,
great.
Thank you. Thank you,
yes.
Tanraj, for that question, right?
Yes.
Sanya,
I understand what Mr. Sanya informing. Is it time? Can I ask one more question?
I know we're supposed to finish at 8. Do we have any other questions?
No,
I have one more. Tanraj, you have one more question?
Yes. So,
okay.
When MPC racing, I seen the only variation in particle counting, but how to check these particles, because normal elemental analysis, ASTM 5185, we are unable to identify this type of varnish products. Particularly, it will give lot of number of particles, whether 4406 or 4407 methods, ISO.
Okay.
But in what other method we have to identify, like UFTR, you are informing, but unfortunately, our FTR can measure only oxidation, nitration, this type of thing. But is there any other method like EDX or XRF? But unfortunately, that one we have the detection limit high, not more than 1000 ppm. So, but some of the particle less than 500 or 200. So, how we can identify these particles are related to MPC value high and a high particle because of the MPC? Because normal analysis, as per used oil analysis, we are unable to find other than additives. Like bare metals don't have.
Yeah.
And so suppose here rubber degradation or o-ring or breather are inside some non-metallic items expired, but the maintenance team unable to identify those rubber items, gaskets. So it is deteriorated and circulating in the system. Whether it will form a varnish and how to identify that one.
Oh boy, you just gave me a very loaded question that I need to answer in less than a minute. Thanks for that, Tanraj.
But okay, you can take later. You can communicate with some email or WhatsApp or something.
We can definitely try with that. But I think ideally what we can do for those type of things is that we can trend, because when you're doing the particle count, ISO 446, that will help you to trend your level of particles, but it may not tell you exactly which particles are related to varnish and which ones are not related to varnish. So I understand your concern there. There are some other types of tests that you can do. Maybe the CPA might be a better alternative there in terms of helping to identify your level of varnish, or if you have some sort of precursors in it. So that's one I'd want you to look at, and maybe PQ index as well. So I will probably send you a note on that when I get a minute. So okay, I know we have another question though, and I know some guys have been here since earlier on. So thank you, Tanraj.
Thank you very much. Yeah.
Thank you, Tanraj. Sanya.
Yes.
Do you have a slide with your contact information?
Oh.
I'm seeing one or two. Yeah, I'm seeing one or two questions that might require
some longer answers.
Yeah, they could personally contact you. So, like example, Jamie Gallagher is asking, do you have any examples of the MPC patches to show you different limit ranges color-wise?
Oh, right? The colors are going to change so much, Jamie. Yeah. It depends on what type of deposit it is.
Well, he wants examples. So that's something that could be covered via email. Like that. I have a question, a spin-off from your twin zone, right? With regards to training and knowledge base and learning resource, is there any learning resource center that you could learn about varnish in further depth from your presentation that could lead to possible certifications, the ICML certifications with Varnish and
yes,
stuff?
you have the Varnish badges. The Varnish badges are a great source of information if you want to find out more about Varnish. The book that Greg and I wrote, actually, that kind of covers a lot about that. So it covers content for the exam in addition to a little bit more, and we have some case studies in it. So I think I had the book at the beginning of it. It's called Preventing Turbomachinery Cholesterol, The Story of Varnish. And in that book, we actually have some questions at the end of it, which are like sample questions for the exam. And the good thing about it is that even though they are multiple choice, we give reasons for those answers. So if you're, looking at some sort of questions and you look to the back of the book, because that's where we have those, you can see the reasoning behind choosing a particular answer. So it may give you some insight into what you may want to ask about.
Well, guys, I got that. I got my copy of the book.
Yes, you got your signed copy.
Monday. Yeah, so it's a must read for sure, right? And that book will be only the resource when it comes to preparing for your Varnish certification.
So far, yes.
So far, all right.
So far.
All right, no problem. Anthony Grant, you have any questions? You usually have a lot of questions.
Oh boy. Maybe not.
Right, no, right. You can. I saw you had your hand again before. You have a quick question?
Oh yes, he has his hand up again.
Yeah, could you unmute?
Oh yeah, I think your mic needs to unmute on your side. I guess you're gonna have to try and reach me on LinkedIn then.
Yeah.
Yeah, you may have to try and reach me on LinkedIn then.
So any of you who have any further questions for Sanya, you could reach her via email or via LinkedIn or even via Facebook. So
yes, definitely.
Sanya, thank you very much for your time.
You're almost welcome.
All this knowledge shared. We will definitely request that you come back again to present. Thank you, everyone. Thank you, Sanya.
You're almost welcome. Yes. I'm glad if I helped in some form or another. So just, reach out to me if you have any questions, and we will be chatting soon.
Yes, sure. Thank you very much, everyone.
All right. Bye.
Thanks, Sanya. Bye.